Well, I'm tired of laying down law. You don't care to listen, you don't care at all, and you don't understand as to what it means to be with a man like me, yeah. Treat me kind with love all the time and tell me for what you need, yeah. The first time I trouble, you're gone to the devil, and I don't mean to burst your bubble, but I love you, and now I'm gonna miss you, and bye-bye. And I'm tired of breaking down the wall. You just keep your distance, and you don't care to call, and you don't understand as to what it means to be with a man like me, yeah. Treat me kind with love all the time and tell me for what you need, yeah. First time I trouble, you're gone to the devil, and I don't mean to burst your bubble, but I love you, and now I'm gonna miss you, and bye-bye. Come on, boy! And I'm tired of waiting for the fall, and you make no commitments, you can't have it all, and you don't understand as to what it means to be with a man like me, yeah. Treat me kind with love all the time and tell me what you need, yeah. First time I trouble, you're gone to the devil, and I don't mean to burst your bubble, but I love you, and now I'm gonna miss you, and bye-bye. Take it home, boys! Come on! And I'm tired.
All right, so today we're going to start designing our own databases, but before we do that, let's finish up what we couldn't finish up last time, where remember that we started out with, the idea that we have this flat data model. We didn't show it for the video game database, but we showed it for the enrollment model, right, when you're in a student is enrolled in a class. And now we want to bring it full circle. What we want to do is we want to take this relational data model, which again looks like this, with publishers, games, and platforms, with a one-to-many relationship here between the publisher and the game, and a many-to-many relationship between the platform and the game, so that one game can appear on multiple platforms and vice versa. And what I want to do is I want to take this entire relational database model, and I want to collapse it down to that flat model yet again, right? So we started out with, last time, selecting everything from publisher P. Then we left joined over to the game table. So we started from the left and went all the way to the right here. Publisher to the game, game to the availability, availability to the platform. And when we did that, we all used left joins. What's the difference between a regular old join and a left join? It preserves records from the left, right? So if you start out with a record here and there's no matching record in this table right here, then with a regular join, that record gets lost and dropped. But with a left join, it is preserving those records all the way across. And as we saw, we need to do that for every single one of these. Why? Because if at any point there is no match, A to B to C to D, right? There's no match, it gets automatically dropped from that result set. So we had to have left, left, left. Let me go ahead and execute this and show, oops, I need to use my database here. There we go. And once I've done that, there we go. We get, say, LucasArts, they produce Lego Star Wars, and you can see that it's available here on 4 different platforms: Xbox, PlayStation 2, PC, and Mac here, right? But Sony Entertainment, they never had any single game published at all in this database, so everything to the right is now null. Whereas, say, Rockstar Games here, they published GTA 3, but it was not available on any system according to this database, okay? So some things get lost along the way unless you do left join, left join, left join. Now let's take a look at all the platforms here. Xbox, Xbox 360, some older platforms here. Down at the bottom, we have PS5, Switch, Steam Deck, and Valve Index. Let's see if we've got any games that show up with any of those platforms. Let me go ahead and sort the platform by platform name here. And do you see any games represented by any of those platforms? Nope. Why? Because those are too new of systems. We don't have any games in our database for any of those platforms yet, right? Switch is not new. What is it, 6 years now? Something? I don't know. Anyway, that's because we started over at the publisher table, went to the game table, availability table, platform table. We preserved records from the left, right? Unfortunately, when we get down over here to the platform table, right, there are no records that are available on the Steam Deck. So therefore, we don't get those platforms represented in our data set. So what I want to do is I want to do the opposite direction. I want to start from the right and go all the way to the left. Right? You can do that, or you can do the same exact query and preserve things from a right join, and right join. Remember, there is a right join, all right? It preserves records from the right. It's just that I rarely use it because I read from the left to right, like most people, right? And so I like to join from this table to that table to that table and preserve left, left, left. I could rewrite this query to start at the platform table, then go to the availability table, then go to the game table, then go to the publisher table. Or I could have the exact same query, but instead preserve things from the right. So it's difficult to read from the right to the left now, or top to bottom to top, but it saves me in typing. I just change left joins to right joins. Let's go ahead and see if that solves our problem here. Now you see down at the bottom, we've got PS5, Switch, Steam Deck, and Valve Index, and everything is now preserved to the right because of right joins. However, what we've lost here is, say, Sony Entertainment. Remember that it's only being preserved from the right or the left, but not both. So you might ask yourself, well, can you do a left, right, BA start kind of thing? No, you can't. That is not, that's not correct syntax. So I've got one result set and I've got another result set. In math, if you've got two sets, how do you combine them into one? Say what? What operation is that called? Union. Right? So let's union these two things together. Right? And we get all of those records all together at once. Right? That result set, and all I had to do was union them together. Right? And now I've got, where is Sony Entertainment? Somewhere at the top, probably. Yeah, there's Sony Entertainment. They're preserved all the way to the right. There's the Steam Deck, and it's preserved all the way to the left, right? Left, right, depends on how your perspective. Right? There's a single query to dump all of that data into one flat representation. And by the way, if you want to preserve, or if you want to export this as something, say, for example, a CSV file, you can do that, right? That's exactly how I would have done it if I had assigned this as your first assignment. Right? It's been the first assignment in the past, but not this semester. By the way, another thing that you should realize is that when you go to start generating data for, not for this phase, but for the next phase, when you have to implement your database and insert test data, that same CSV to JSON, same CSV to XML website that we recommended, I think it's csvconverter.com or something like that, You'll note, if you go back there, you'll note that there is a CSV to SQL statements. And so yet again, you don't have to write too much. You can just go ahead and rely on that website. Right? All right, any questions so far? Otherwise, remember that we are online, so if you have any questions, go ahead and post to the YouTube live stream here. What I want to do now is I want to start from, we were given this database to play around with, right? I want to go ahead and start from scratch. I want to design the database and then implement the database and then maybe insert some test data along the way. Our motivating demonstration here for this tutorial is going to be our, the annuity, the savings account application that we had before, with one little twist. We're going to allow accounts to be owned by multiple people. Right? So just to refresh our memory here, here is the UML diagram that we ultimately created for an account, an annuity, and a savings account when we went through object-oriented programming. An account is owned by one person, at least according to the version we did in Java. That person has a first name, last name, date of birth, emails, right? And how many emails do they have? More than one, right? So there's the model that we want to do. Let's work this together, work it out together, and do a whiteboard. So this is my whiteboard. This is my just my iPad and my notepad here. Help me out. How many tables are you going to want? Give me one table to start with. What's one obvious table that we should have, probably? A person. Okay, I like that. Let's come over here, and let's think about a person. Right? So I'll go ahead and create this table here. In other words, I'm going to start sketching out an ER diagram that looks something like this. Okay? So a person table. Should I call it persons? I didn't do that with the classes. Why? It's not the persons table. It is the person table that holds persons records. Right? Besides, what if I did pluralize it? What is the plural of person? Persons or people, right? So don't get into that trap of trying to think of clever names for your tables. Name them what they are. Keep it simple. Singular forms. I've also used a upper camel casing convention here. This is a modern convention that I would suggest that you use. Why? As you saw from this UML diagram, our POJOs, our plain old Java objects, are going to have a one-to-one correspondence with our tables probably, right? For the person table, there's going to be a person object. Well, what if you named them the same thing, right? Then that takes a lot of the guesswork out. Right? All right, so what should belong in the person table? Their name, okay. Just a name. All right, so first and then last. All right, I like that. Let's come over here to our other database over here, and let's think about this. What do you see in every single table? What is that little gold thing there again? A key, a primary key. So let me come over here and just note that down. A, and this is my best key. There we go. All right. Sorry if it looks like a person, but that looks like a key to me. All right. I don't know. Look good enough for a key? And here, I'll write it down as a PK just to show you that it is a primary key, right? I guess I could change over to gold here. There we go. And come on. There we go. There's my gold key, right? Color and everything. What should I call that primary key, by the way? What naming conventions did we use in this table over here? Person ID, right? Again, take the guesswork out of things. Use a common naming convention for everything. If your table is named game, then call it the game ID primary key, right? So I'll go ahead and call it the person ID. There we go. All right. What else defines a person? At least according to this. A date of birth? Okay. I mean, it's not that hard. If you've already designed your objects well, right, then this next phase of designing the database, all you have to do is translate things over. There's a one-to-one correspondence between them, okay? So probably a date of birth. Now, before we move on, these two are obviously going to be strings. Right? And in terms of database, that means that they're going to be varchars, right? Variable character arrays. Right? But what about a date of birth? How did we do that over here in Java? Did we? That doesn't look like a string to me, though. That's a local date, right? Over here, how are we going to do it here? Is there a Java local date built into SQL? No, that doesn't make any sense. So I'm going to go ahead and leave that as a question mark here. We'll see that there is a built-in date type in SQL. It is not at all interoperable. It is not at all compatible with other things. So ultimately, what we are going to do is a string. What would today is March 8th, 2023. Should my string look like this? March 8th, 2023. Is that how we proper computer scientists do dates? Nope. Should it look like 2000, or what is it, March? So 3/8/2023. Is that how we do it as proper computer scientists? No, that's the American way. The European way is also wrong. What is the only correct way? ISO 8601 standard 2023, 03, padded out zeros, and 08. Right? Anything else is not lexicographically orderable. It is not good data. All right? You will have a huge, terrible time dealing with dates like this. You will have just as a worse time as dealing with dates like this. Yeah?
On an earlier version of my assignment, instead of using local date, I just did that formatted string. Is it possible to take a string like that and convert it to a Java local date, or do I have to?
Yeah, parse, I think local date dot parse date or something like that.
Similar to just
Yeah,
parse.
although I don't think that in an earlier version, like you mean from phase 1, I don't think phase 1 had any dates, did it?
I thought in person I put like a date of birth string. No, it might have been something.
That's okay. That sounds Yagni. You ain't gonna need it. That's not part of the assignment. All right. So there's the only possible way. So in other words, ultimately what we're gonna do here is probably another varchar. Again, this is whiteboarding, right? We're throwing out ideas here, and ultimately we cross them out and go, yes, this is the right one, right? And then ultimately we go ahead and clean that up, put that into our design document. Ultimately, we design, once we've got everything implemented, we output an ER diagram that looks like this and replace our sketch, okay? All right, what else is a person over here according to our exercise over here? A bunch of emails. Right? And in this case, emails were strings. You could have gone with like an email class. Yagni, you ain't gonna need it. Right? So what should I do here? Should I put in email 1, email 2, email 3? Does that sound like a good strategy? Probably not. Right. This actually would violate first normal form. We'll get into first normal form, second normal form, third normal form later on. But this violates that. Because what if you've got 4 emails? What if you've only got 1 email? Then you are wasting memory. You are wasting these two right here. Right? So, nope. How do we do this? If I've got 1 person and they can potentially have many emails, what should that be screaming out to you? Well, if we've got 1 publisher and they've got many games, what is that screaming out to you? 2 tables. And what kind of relationship between them? An email table. There we go. And a person table. So what kind of relationship between them? 1 person to multiple emails. Right? There's my chicken foot scratch. Right? What is an email? Okay, it's a string, say an address, and that's a varchar. Again, in terms of a database, strings are varchars. Okay. What else? Is that all in the email? So whose email is it? We've got Joe over in the person table. Joe's got 2 emails. Joe at gmail.com, Joe at unl.com or unl.edu, right? How do we know that those are his 2 emails? Some kind of key, right? Some kind of, how did we know that this game over here was by this publisher? The publisher ID, that was called a foreign key. So look at the relationship here. This is the parent table. This is the child table. The child refers back to its parent through its foreign key. So where is the child in this case? The child here is email. To refer back to the parent that owns it, the person that owns that email, what else do I need here, in here? Person ID, right? And I will label that as an FK, right? FK, short for foreign key. Is there anything else I should put in that table? In fact, what should I have done first and foremost? What is done first and foremost in every table, period? Email ID, primary key. Right? So, email ID. Right? You start to see patterns here. Right? We like to be predictable in computer science. Why? Because predictability means that everything goes smoothly. Right? All of engineering, you like everything to be absolutely predictable. I had a structural engineer colleague point out that if it were up to structural engineers, there would only be square buildings and nothing else. Why? Because that's the most predictable, that's the most stable, that's the easiest to design, right? And then, of course, architects come in and they want all this fancy stuff. And then it's a challenge. You know, we like square boxes. We like predictability, because predictability don't break. Right? All right, what else do we need here? I've got the persons, I've got their emails, accounts somehow. So for now, what I want to do is just come over here and write some notes to myself. I probably do want some sort of a account table. What's the first thing I should do before I proceed? Primary key. So PK, account, right? Except that, wait, there are 2 types of accounts. There's an annuity and there's a savings account. So do we have the same kind of inheritance concept in the relational database management model? No, we don't. Why? Because Edgar Codd here back in 1970, when he first came up with it, predates object-oriented programming by at least 10, 15 years. They were not thinking about inheritance. They were not thinking about polymorphism back then. So we have a fundamentally different type of data model versus a Java model that has inheritance. Object-oriented programming, over here, we've got relational modeling. Right? So how are we going to do these 2 things? Right? You can kind of spitball it and think about it. We'll come back to it. For now, though, I want to focus on implementing this, because I do actually want to write some SQL today. Right? So we've got a person table and an email table. Let's come over here and start. You can create a table using create table. Who would have thought, right? This is exactly how you create a table in MySQL. There we go. And what should I call this table? Well, what did I spitball over here? Upper camel cased, and I called it person. So we will call our table person. There you go. Opening parenthesis, closing parenthesis, semicolon here. Anything that you put inside of here is going to be part of that table. So you define the columns, the column types, and a couple of other things that we'll talk about here in a second. Okay? So what is the very first thing that I identified in my sketch here? Primary key. Right? So person ID. Right? It is an integer. Right? You can go ahead and go with int or integer. Why? Keep it simple. Int. Right? Int primary key. Right? 2 words, not null, and auto increment. I'll walk you through each one of these in a second here, But that is what you should do for every single primary key, right? You should only use integers. Strings are not good. Why? Because as everybody's seen, my project is not working because I misnamed all of my files all lowercase instead of capital P persons.csv or something, right? Everything that matters in computer science, everything that matters in data is case sensitive, right? All right, so it's not, if you've got a string represented as your primary key, then you've got case sensitivity issues both in the data, in the table, in your collation, and in your queries. Get rid of that headache. Integers are integers, and ain't nobody changing an integer anytime soon, right? So an integer, primary key, not null. Primary key designates it as the one and single primary key. You can have other secondary keys. You don't call them secondary keys, but this is how you get that one primary key. If I had another one called foo primary key, right, that is not going to fly. You can't have two primary keys. Primary is primary. There's only one. Not null means that you are not going to be allowed to have a null value. It'd be kind of pointless anyway. Everything has to be unique for a primary key. So if you had that one null value, you can never have another null value. So what's so special about this, right? Not null. We're not going to allow it to be null. We're going to let the database take care of it for us. Just like with the video game database, if I put in a new game, another new game, and another new game, it automatically took care of that key management for me. I'm going to let the database do its job, right? Note here that it is an underscore. Yes, it is inconsistent. Don't ask me why. Then I've got a comma here at the end. That's the first column. What's the next column that I want? Let's come over here. First name, last name, date of birth. Okay. First name. Note here, now you see my pattern already. What am I naming each one of these columns? What convention am I using? Lower camel casing. Why am I doing that? Because that's what it is in Java, right? If I'm eventually going to be loading this stuff from a database into Java, Java into a database, everything has a nice, clean mapping between each other, right? All right, so first name, what's its type? String. Unfortunately, there is an alias supported, and you can call it a string. Don't do that. Varchar, 255. There we go. So what is varchar again? Varchar is variable character. 255 is the limit that I put in there. So if I had somebody with a first name of 256 characters for whatever reason, then that last 256th character would be cut off. You can always make it bigger, 1,000. You can always make it smaller. Nobody's name is that long, 50, right? 255 is very, very common for historical reasons. It's one fewer than 256. And 256 is a perfect square of 2 to the 8th, and 8 is exactly 1 byte, right? So there's a history there, right? We also have the last name, varchar 255. Right? Now, by default, everything is allowed to be null, right? If you don't want it to be null, then you have to put in this keyword here. So I could put in a person without a first name, right? And it ends up being null. I could put in a person with a last name, and maybe it's allowed to be null. By default, it's allowed to be null. Should we allow that or not? No? Okay. Then let's not allow it. Varchar 255, not null. There we go. What about a first name, though? I don't know. Might be cultures where there's somebody with only a last name, like a family name and no first name. If I were doing this if I were redoing the albums database, of course, we would have Prince, right? One single name, right? And, well, what do we put in for his first name? We put in an empty character, an empty string, or we allow it to be null, right? So, allowed to be null. Maybe. I'm putting this in as a comment, and I'm going to put in a question here. Because then at that point in real life, this is a real project, you'd be going back to the stakeholders and saying, is that required data or not? Are you ever going to have somebody with a first name and no last name? And then, of course, you'll get your answer. This is called requirements elicitation. You're eliciting a response for them on what the requirement should be. And then this is also where you don't trust them, and you go back to the test data and see, nope, there are 50 instances in your old data that you want to import into this new project where they didn't have a first name. So no, that business rule is not true currently. Should it be true in the future, right? And then go back to them and have that conversation. Right now, I'm just going to go ahead and say allow it to be null just for variety, okay? Is there anything else? Date of birth? So let's go ahead and put that in. Date of birth. Actually, date of birth. Varchar, and I'll put in a question mark there. Can I have columns with spaces in it? You can if you backtick it. It's not a good idea. Remember, these are backticks, and you can put that into an alias and have spaces in your column names. Don't do that. Weird. Date of birth. All right, there we go. Varchar. Should I go ahead and do 255? There's going to be, if we're proper computer scientists and we're using ISO 8601, it's going to be 4 for the year, hyphen, 2 for the month, so we're up to 8, hyphen, 2 for the day, 10. Let's just go ahead and make it 10. That way, if anybody is putting in that March 8th, 2023, it'll be truncated out and removed and rejected. Right? What if they don't specify a date of birth? Right now, we're not going to allow it to be null, say, not null. So if somebody puts in a person and they just haven't gotten their date of birth, somebody's setting up their accounts at the bank, they were just not, oh, I forgot my date of birth for whatever reason. Or they were setting up an account for their significant other or a cousin or something like that. You know what, I forgot the date of birth, I'm going to have to get back to you. Great, that's not going to prevent me from setting up your account today. I'll just go ahead and put in a dummy value, a default value. We'll let the database do it for us. 0000000. There. That's our flag value to indicate that we don't know what it is. That is certainly not a valid date. And now if in your actual application, you loaded this up and you tried to parse it out as a local date, it will get an error thrown. And you know something went wrong. Right? So maybe this is a good idea, maybe this is not a good idea. Again, what would you have to do? Go back to the stakeholders and ask, should we be doing this? Right? Through your requirements solicitation phase, right? Or your requirements gathering. Don't ask me why they use a fancy word for it nowadays, but yeah. Is there, so the question for anybody that can't hear online, is there a way to enforce good formatting here? Yes, through a check constraint, but MariaDB doesn't support it, and I'm not sure how to do it off the top of my head, and I'm not sure at all if you can do it using a regular expression, because the regular expression here would be 0 through 9 times 4, 1, 2, 3, 4, followed by a literal hyphen, followed by 2 0 through 9s, followed by a literal hyphen, followed by 2 0 9s. There's your regular expression that would force good data. That still does not force correct data, right? You could still have February 30th, 2023, right? At that point, maybe you do want a date, right? Foo date, right? And there is a built-in date type. Cross your fingers because it will not port over to any other, like if you take a date on a MySQL, it's probably not compatible with Postgres. That's probably not compatible with a SQL Server. Not compatible, not compatible, not compatible. I would say stay away, right? Stay far away, right? But good question, right? That's good for now. If I put in a comma at the end, right, that will be a syntax error. A, comma, B, comma, C, that's it, okay? Anybody coming from a C background, you'll recognize that as the Oxford comma encoding that you put at the end of a list of an enumerated type, right? We don't do that in SQL. You can't do that in SQL. Okay. Great. What's next? Email table. So let's do it up here. Create table email. And I'm going to go ahead and go on speed mode here because we've already seen the patterns. Email ID, int primary key, not null, auto increment. The actual address, which is a varchar, 255, say. And you might ask yourself again, can you enforce good formatting here? Can you enforce at least a valid email? Not easily, right? Not null, because if it's null, then why do you have this record, right? Got a person with no emails, then they should have no email records in that table, period. You shouldn't be you shouldn't put in a record, I don't know what their email is, right? That's not how it works, right? And end it. There we go. Now, I don't have this one-to-many relationship done yet. Remember, we have a primary key in both of those. We already said that we wanted a foreign key here in the child table on the email table. So let's go ahead and add that now. Person ID. Okay. What type should it be? Should it be a varchar? 255. Does that match with what we're referring to over here? Nope. So they also have to match. Int. Not null. Why am I not going to allow this to be null? Can a game exist without a publisher? No. The reason that it can't is because I said that this publisher ID cannot be null. If I allowed it to be null, then that would kind of still have this relationship here, but you could have orphans with no parents at all, right? You'd have this orphan game with who's their publisher? We don't know, right? They're just off in the ether. They're orphans. We do call them orphans, right? I'm not going to do that here, so not null, okay? Now, how do I bring these two tables together by specifying that this person ID is referencing this person ID in this table? To do that, I say foreign key, got to spell it correctly, foreign key person ID, right? References person ID. There we go. So to read this references, I spelled that right. References. Well, what's wrong? I might not like it without backticking. Not valid at this position. Person, okay, fine, I'll backtick this. Nope. I'm not sure why, okay, all right. I didn't have to do this before, but whatever. All right, so put in parentheses, sorry. Foreign key, person ID, references person ID. Again, reading that is, this person ID here is a foreign key that references this person table down here, and within that, it references the column person ID. And because I named them the same thing, right, I'm good to go here. Now, sometimes you can't name them the same thing. For example, if you've got, say, an invoice that has a person that is both a salesperson and then a customer, right? You're not going to be able to name them both person ID. In that case, you do need to use a distinctive name that this foreign key is probably going to reference that person as the customer, that person as the salesperson, right? Or that person as the service person if it's associated with service, right? Okay, let me go ahead and try to execute this entire thing. Well, first of all, let's go ahead and, let's see. Execute the entire thing? Okay, there we go. It failed. Error code. Cannot create table. Why? I cannot create table, email table. Foreign key is incorrectly formatted. So what's the problem here? I've got an email table that references the person table. As of these first 7 lines of code, does that person table exist yet? Nope. So what does that tell you about order? Order matters. Let me go ahead and move this up here, and now let me execute it all again. Let's go ahead and clear this out. All of it. 2 green check marks here. That means that it went well. Okay. What if I were to run this again? Can you create another table named person if a person table already exists? Nope. Red X. Right. So if you are going if you're iteratively developing this stuff then it's kind of a pain in the butt to to get rid of those tables and recreate them if you have a change. For example, we misspelled date of birth, right? We need to come back and make it into a capital O here, right? So the way that you can get rid of tables is to drop table person, drop table email. There we go. Now, I'm going to go ahead and try to execute this first one. Am I going to be able to drop that person table? Nope. Why? Could I drop the publisher table here? Nope. It has a bunch of things that refer to it. If we were to get rid of this table, then everything in this table would now become an orphan, right? And we don't want that. So if I create it in the order of person, then email, because email references back to person, what order do I need to delete them in, to drop them? In the reverse order. Oops. Drop the email table, the child records, then you can go ahead and drop the parent table. What order would I have to drop everything in here in order to delete this entire database? First, I'd have to do availability. Once that separates and severs the connection between these two tables, I can do either one of those in either order, but I have to do the game table, the child table, before I do the publisher table. So I'd have to go availability, platform, game, publisher. Bottom up when deleting, top down when creating. All right, let's go ahead and try that now. Drop table email, drop table person, great. Now I can run it all at once. Oops. It dropped. Can you drop something twice? Can you delete A and then delete it again? Nope, that's what it's complaining about here. Unknown table email. So it's even better if you put in conditionals. I only want to drop that table if it exists. I only want to drop that table if it exists. I only want to create this table if it does not exist. Bad grammar, yes, but that's what it is. Right? If not exists. That way I can run the entire script all at once without having to worry about it failing somewhere in between. Now, those tables didn't exist, so I get this new error here. It's not even an error, it's just a warning. You said drop table if exists, it doesn't exist, so warning, I'll warn you about that, but I'm going to go on with my life here. This is the script talking now. Right? So drop the table if it exists, drop the table if it exists, create the table if it doesn't exist already. Right? Okay, great. I can run this as many times as I want. Now, without ever having to worry about order, without ever having to worry about, okay, do that one and then that one, but I've already deleted that one, so I need to recreate that one, right? Just don't worry about it. Right? Use those conditionals instead. Okay? That looks great for those two tables. Done. Ship it. At this point, I'm going to ask the question of how do we handle this? Right? So let's think about an account, first of all. Let's look at the UML diagram here. There are some things that all accounts have in common. For example, the account number, which is probably a varchar maybe, I don't know. Right? Over here in the annuity, we have a monthly payment and the number of years. But over here in savings, we have a balance and we have an annual percentage rate. So you might be looking at this UML diagram and be thinking, okay, well, I just want a one-to-one correspondence with my ER diagram. So what we're going to do is we're going to create 1, 2, 3, 4 tables. Right? And then maybe this one refers back to this one somehow, right? Maybe it's a one-to-many relationship, or maybe it's a one-to-many relationship in the other direction. Or maybe it's actually because there's one account associated with one savings. Maybe it's a one-to-one relationship. If you have yourself thinking that, why do you have two different tables? If there's one record over here that refers to one record over here, that is a huge red flag, a code smell, that you may want to combine these two into one. Again, it's a relational model, not an object-oriented programming model. There's no such thing as inheritance. So why try to simulate inheritance with this thing? Right? You can do this, by the way, if you really want to. I would advise against it because you have 1, 2, 3 tables. Why do 3 tables when one will do? What one does job well, whatever. What is the quote? It's from The Office, right? Why use many words when few words do trick or something? Is it trick? Okay, yeah, there we go. Right? So there. Why do 3 tables when one will do the trick? Right? So let's rethink this. I'm going to go ahead and make it large. Right, there we go. And here's the account table. So what's the first thing that I should do? Primary key. Account, ID, primary key, auto increment, not null, ... The rest of that stuff. Before I go on, let's take a look at our model over here in the UML diagram. I also have a distinguishing characteristic, a way that I can define uniqueness here. Account number, but it's a string. How do I reconcile the idea of using a primary key over here as an integer, and it is an integer, right, versus an account number, which is a string, because it can have, you know, letters in it. It can have hyphens in it, right? Well, if you want both, do both. Right? Account number, which is a varchar. Right? And then I'm going to put off to the side here, we need to ensure uniqueness. Right? Nobody else, you shouldn't have 2 accounts with numbers 1, 2, 3, 4A, right? Because your account is 1, 2, 3, 4A, my account is 1, 2, 3, 4B, and I'm sure that you don't want your money going into my account, right? That's fine with me, but not fine with you, right? So we're going to have to ensure uniqueness somehow here. That gives us a question of, well, are these both primary keys? Can you have more than one primary key? No. You can have what I called a secondary key or a surrogate key. Right? So a surrogate key versus a natural key. To understand this, let's think about a real world situation here with a person. Right? How do we uniquely identify a person in the United States? A social security number. How do we uniquely identify somebody here at UNL? An NUID number, right? These are called natural keys, right? So for natural keys, say social security numbers, NUID numbers, right? These are natural keys that have been created by another system, the Social Security Office or whoever they are, or whoever creates NUIDs. Do you think in the history of the United States, the Social Security Office has never made a mistake? Do you think in the history of NUIDs, UNL has never made a mistake? A mistake being issuing the same NUID to 2 different people or issuing 2 NUIDs to one same person. In fact, I think it happened in this class because there were 2 people by the same name, and then one day with 2 different NUIDs, and then the next day there was only one because they had collapsed their NUIDs because they had registered, you know, many years ago, and then they came back and they accidentally issued them a brand new NUID. What if we always trusted the NUID office, whoever they might be, right? We're going to always trust them to do something, to always never make a mistake. Is that a good assumption? Probably not, right? So we're not going to allow their mistakes to screw up our database, which is why we will keep them separate. Natural keys, yes, we want them. We want them to be in our database, maybe varchars. We'll want to ensure uniqueness, but we will not want them as primary keys or foreign keys that determine the integrity of our database, because then that means that you're trusting them to never make a mistake, or the second that they make a mistake, your data is screwed up too. Right? It is so easy to come in and change one field of one record versus, something changed in one table, that is also used in this other table, and it's also used in this other table, and it's used in 5 and 6 other tables. Now you have to write a big giant query to update it in every single spot and make sure that you don't make the same mistake that they made. Right? Don't let outside values like natural keys dictate your integrity, your data integrity. Yes, keep them. Yes, ensure uniqueness. Keep them unique and keep them in your database, but do not let them be your primary keys. Okay? So, great. What else goes into an account with only 4 minutes left? Is it obvious? Monthly payment, number of years, balance, and annual percentage rate. So at least those 4 things. But wait a second. 2 of them are relevant if it's an annuity account. 2 of them are relevant if it's a savings account. We already made the decision not to separate them out. Right? We made the decision to use one table. This is a single table inheritance strategy. Right? So how are we going to distinguish them then? Type. I like that. And it's going to be a varchar. In fact, a single varchar if you want. Not E. What? A or S for savings. Right? I like that. And then to do the rest of this on Friday. Right. Any questions? Otherwise, I'll see you then.